In this video, we're going to do another question on the trapezium rule. This is question number 2, and in part A, we're asked to sketch the curve y is equal to x squared minus 4x plus 2, showing any points of intersection with the coordinate axis. Okay, so let's find now the value of y when x is 0. So we can say now when x is equal to 0, y will be equal to 0 plus 2, so y will be equal to 2. Let's now look at when y is equal to 0. So when y is equal to 0, 0 will be equal to x squared minus 4x plus 2. This isn't going to factor, so we can either use the quadratic equation or complete the square. I'm going to complete the square, so we'll have x minus 2 all squared, then we'll have minus 4 plus 2. So that's going to give me now 2 is equal to x minus 2 all squared, and solving, taking the square root and adding 2, we can say 2 plus or minus the square root of 2 is equal to x. So let's go ahead and draw this. What we're going to have is a parabola. We're going to have now the point 0, 2, where it crosses the y-axis. Then we'll have 2 plus root 2, 0, and 2 minus root 2, 0, where it crosses now the x-axis. So it looks something, give or take, like so. So we'll come round and the parabola opens upwards. This is going to be the point now 0, 2. This is going to be the point now where we have 2 minus the root 2, 0. And this point right here is where we have 2 plus root 2, 0. So that's part A done. In part B, it says, using the trapezium rule with 4 strips, find an estimate for the area trapped under the curve y equals x squared minus 4x plus 2 between the lines x equals 5 and x is equal to 13. So what we've got then is some way further up here. We're just going to use the trapezium rule now with the 4 strips to find an estimate. We've seen that the area using the trapezium rule is approximately equal to h over 2, the first plus the last plus 2 lots of the other values added. So others added. If you haven't seen the first couple of videos, please watch those as I go through this in detail. So what we got then is 4 strips. Formally, we can say that h is equal to b minus a over n. So what we're going to have then is h is going to be equal to. So we've got now b, which is going to be the 13, minus now 5, so 13 minus 5, and we need to divide this by 4. N is the number of strips, so we can see that h is going to be 2. What I'm going to do is set up a table now, and we can plug these values in. So we're going to have an x and a y coordinate. We have now 4 strips. 4 strips gives rise to 5 ordinates, as we saw in the last video. So we have x and y. We start with 5, then I'm going to add 2, which will be 7. We add 2, which is 9. We add 2, which is 11. We add 2, which is going to be 13. So all I'm going to do is simply set this up and substitute in the values. I can probably do the first few off the top of my head. It should be fairly straightforward. First one looks like it's going to give 7. I'll set it up just to make sure that I'm not getting this wrong. So the way that I would do this now is set up the x squared, and starting with x is 5, so we would just substitute in. Then we've got now minus 4 lots of the value that we're going to sub in. This time we're going to sub in 5, and then we're going to add 2. So that should give me 7. Then if we switch this over to 7, again you can do it mentally if you wish. I'm going to just put them in, so that's going to be 23, that can go just there. Then we're going to switch this over, we're going to end up putting in 9, so let's put in 9. So if we switch that now to 9, that's going to give me 47. Then we're going to do now 11, so plugging these values in, so that's going to be 11. And these are nice numbers, they're coming up to be integer values. Often you'll be expected to give your answers to 3 significant figures in here, especially if it's a messy function. And then finally we have 13, so 13 can go in here, and we can plug these in. So what do we end up with on that one? 119. Okay, so 119. So using this right here, what we're going to do is simply substitute in. So using 4 strips, we can say that the area will be approximately equal to h over 2. So 2 over 2. We will have now the first is going to be 7, plus the last, which is 119, plus 2 lots of the other values, 23 plus 47, plus the 79 added up. This will give us an estimate, so let's go ahead and put these in. So what we're going to have then is, that's going to give me now 2 over 2 is 1, so that's going to be 126, just for 7 and 1 9, plus now 2 lots of the ones in here added up. So we're going to have 23 plus 47 plus now the 79, and that is going to give me now 424. So we can say now that the area is approximately equal to 424, and that will be square units. So that is using the trapezium rule now with 4 strips. In part C, it says state with the aid of a sketch whether the estimate found in part B is an overestimate or an underestimate. So if we look now, this is concave, and we can say that this is going to be an overestimate. So what we're looking at now is the parabola, and I'm just going to draw these on. Let's just go ahead and do this. Again, this is something that we've looked at in a previous video. If I put the trapeziums on, we can see now that these are going to be slightly now above the line. That is the nature of the curve. So we can say now concave, and we can say that it's an overestimate. So it's concave, and we can say therefore this is over. So it's an overestimate. So all I'm showing now is simply that if we drew the trapeziums, these would be slightly above. Okay, in part D, we need to write down an equation for a quadratic function that would give an underestimate when using the trapezium rule. So if we consider what we need is a quadratic function, well, this time if we have something that's convex or opens downwards, we know that this is going to be, now if we do this one, this would be an underestimate. So let's do that. Let's put the trapeziums in. So it looks something like so. So let's just sketch these up. So all we need here now, and just putting this one in, all we need is some negative quadratic equation. So anything negative will allow us to have an underestimate. So all I'm going to do is simply put now y will be equal to negative x squared, and then we'll have a plus x, and that will be perfectly fine. So that is a quadratic function that would give us now an underestimate as it's opening downwards, or it's convex. Okay, in part E we need to use integration to find the exact area trapped under the curve y is equal to x squared minus 4x plus 2 between the lines x is equal to 5 and x is equal to 13. So what we can say then is the area will be equal to the definite integral. We're going from 5 to 13 now of our function, which is going to be x squared minus the 4x plus 2. We've seen that using a definite integral will give us the exact area trapped under the curve between these two limits, and we looked at that in the last unit. So all I'm going to do is go ahead and integrate this, so we can say now that the area will be equal to, integrating x squared is 1/3 x cubed, integrating negative 4x will be, now we take away 2x squared plus 2x, and we're interested in this now from 5 to 13. Okay, let's put this in the calculator. So what we're going to have then is the following. We will have now the 13, so let's put 13, and we need to cube this. So we've seen how to evaluate a definite integral. We simply integrate the function and then substitute in the values. And let's put in the 13, and we need to square that, plus 2 lots of the 13, so that's going to go in there. And that gives me now 1261. So 1261, so 1261 over 3. Now I'm going to substitute in the 5. So let's go ahead and do the 5. So the 5 comes here. Let's do that. Let's change that over for 5 instead of the 13. And then we can subtract that away. So that looks good. So that's going to be 5 over 3. So 5 over 3. So if we do now, so what have we got? We've got 1261 over 3 minus that answer we just found, which we could just put minus answer, or you can put minus 5 over 3, or you can keep it in the same fraction. That gives us now 418.66 and so on and so forth. So that's going to be 1256. So the area is going to be 1256 over 3. And we can say now that that is going to be on here 418, so 418.7, and that'll be units squared, and I'll just do that to 1 dp, okay, if you want 1 dp or 4 significant figures. So you can see our 424 units, it's not a million miles away, but as you would expect, as these x coordinates are getting larger, the y coordinates, corresponding y coordinates will. Therefore, there will be a margin of error. Okay, in part F, we need to find the percentage error between the answer found in B, which was using the 4 strips, which is this 424, and the answer found in part E. So all we're going to do is a percentage error. So with my percentage error, it's going to be the 1256 over 3 minus the 424, which we found, over the 1256, which is the exact value, over 3, times by 100. And this will give us now the percentage error. So if we just look at this, I'm just going to store this. So this is shift store A, or you could use it as the answer. So recall A minus the 424, and then that's going to be now over A. So let's put this in, and then we times this by 100. So that is going to give me now on here 1 point, and we'll call it 1.27. So we'll say now this is 1.27 percentage, and that gives me now the percentage error. Okay, in part G, we need to explain what would happen to the percentage error in part F if 12 strips had been used in part B. So in part B, we only use 4 strips. The more strips we use, the more accurate. So we can say now that the percentage error would reduce. It would reduce now for 12 strips versus 4 because we're increasing the number of strips. The more strips we include, the closer we can get now to the curvature of this particular graph. So you can see here it's quite a crude estimate, yet if I had one just here, then the top of that trapezium would be now more in keeping with the shape of the curve. So if we did 12 strips, it would now decrease, it would become more accurate or reduce the percentage error. If I had 100 strips, then it again would reduce it further. So there's another question on the trapezium rule.